3, we see DU3 right at center. We see DUs 1 and 2, a couple of clicks above center. We're checking power draw now.
Copy that, Stan, and obviously when we go into eclipse, we can bring them down a bit further.
Roger. And Reed, when we get into eclipse, we would like those extra clicks on DUs 1 and 2.
Yeah, you got it. We did bring 1 and 2 down a touch, but we'll bring them down as far as we can when we get into eclipse.
That's perfect. Thank you.
Booster ignition and liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
Integrity, good roll pitch.
Roger, roll pitch.
Houston now controlling the flight of Integrity on the Artemis II mission around the moon.
Integrity, AMT high.
AMT high.
On time, passing 30 seconds into the flights. Integrity passes the alternate MECO. Target milestone. Mission Control Houston seeing good performance on the 4 main engines. Space Launch System core stage. Integrity, 3 miles in altitude. Traveling more than 1,200 miles per hour.
Good evening and welcome to NASA's Artemis II post-launch news conference. I'm Bethany Stevens, Senior Advisor and Press Secretary, and I will be your moderator today. I am joined by Administrator Jared Isaacman, Associate Administrator Amit Kshatriya, Acting Associate Administrator for the Exploration System Development Mission Directorate, Dr. Lori Glaze, and Director of Flight Operations, Norm Knight. Administrator Isaacman will give opening remarks, and then we will open the floor to questions. If you are dialing in to be with us here today, please press *1 to get in the queue. And with that, Administrator.
Thanks, Bethany. Good evening, everyone. So today, April 1st, 2026, 6:35 p.m., NASA's Space Launch System rocket lifted off the pad with 8.8 million pounds of thrust, carrying the Orion spacecraft and the Artemis II crew out to Earth orbit and beginning America's grand return to the moon. Now, about 51 minutes into the flight, during a planned handover between satellites, the Orion spacecraft underwent a communications issue, leading to a temporary partial loss of comms. The uplink from Capcom to the crew was being heard by the crew, but we cannot hear their responses for a brief period of time. There were no issues with the vehicle itself. Comms with the crew have been restored. We're actively working the issue, and we'll keep you informed. The Orion spacecraft has successfully separated from the core stage, and its solar arrays have been deployed as planned. Soon, the crew will execute the apogee raise burn, placing the spacecraft into a stable, high Earth orbit as we prepare for the translunar injection and the journey into cislunar space. NASA astronauts Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency mission specialist Jeremy Hansen are safe, they're secure, and they're in great spirits. We will continue to monitor their health and the status as we move into the next phase of the Artemis II mission. So after a brief 54-year intermission, NASA is back in the business of sending astronauts to the moon. We have arrived at this point through a sustained effort and national commitment and the work of thousands across the agency, our industry partners, and our international allies. I want to personally thank the ground crews, pad controllers, the entire workforce here at Kennedy Space Center. This mission belongs as much to you as it does to the crew. The crew is now in the capable hands of Mission Control Houston, the Johnson Space Center, where teams will guide Orion through each phase of the mission with the same discipline and precision that has brought us to this moment. We have certainly been here before. We know the challenges ahead. We have a lot of checkouts to get through before TLI. And when, if all goes well, everything is go, Artemis II will be moonbound. You have our commitment to keep the public as informed as possible on this historic mission. And we will celebrate when we will hold our celebration until this crew is under parachutes and splashes down off the west coast of the United States. Thank you.
So with that, we will open this up to questions, and we will start here in the room if we have any takers. We'll start right up here.
Congratulations to all of you on a successful launch so far. My name's Jim Siegel. I'm with Florida Media Now. And I'm curious about when the astronauts will have their first meal on this mission. And secondly, is somebody on the Earth here, back in Houston or somewhere, keeping track of what they eat during this entire mission? And how do they go about doing that? Do they tell them what to eat, or do they kind of select what they want? What do you think?
Well, let's see. I'll jump in on this one. Well, what I'll tell you is they do have planned meals, okay? So they have a planned meal today. I will tell you they're very busy. So ascent day is very tough. It's tough physiologically, and it's tough from a workload issue as well. And so this timeline between now when the crew goes to sleep, so MET of about 8:30 is pretty packed. They're going to snack. They probably have some pre-positioned meals. I know they did in their flight suit. Some of the snacks that they can use if they need. But I will also tell you that flight day 1 and flight day 2, you might not feel like eating a lot, and that's just part of it. Your body is acclimating to 0G. Your physiology is transitioning from a 1G environment to 0G, and it takes a little bit of adapting. So right now they're working hard. They are doing what they need to do. They sound great on the loops. That was really a good signal to us that they're feeling well. But just know that that's part of the equation, when they get on orbit. As far as the food being tracked, yes, we have a food lab, and we have folks at the Johnson Space Center tracking what they eat, the nutrition, the calories. It makes a difference. They do this on Artemis. They do it on Space Station as well. So we're well versed in that. We want to make sure that they're healthy, and we also want to make sure we know what they're doing, what they're eating, so we can also track that and make sure that they don't need any supplements or anything additional.
Thank you.
We'll head over to Joey.
Thanks, guys, and congrats on a clean launch so far. Jared, or whoever wants to answer, how were you able to resolve the communications issue, and do you have any guesses as to what might have caused that? And was there any part of the mission so far that appeared off nominal, or is everything looking good? Just curious to hear how things are going on that. Thanks.
Well, on the comms issue, and I don't know, there may be someone here that has a little more detail than I do of having to run around quite a bit, but I think they're still looking into trying to really understand exactly what was going on there. But it's restored, which is important. I think it just...
It was during handover to Tedros West.
Between
Sometimes that's squirrely. Ground configuration, you gotta get that right. So hopefully that's what it is. But we'll chase it down. But they were able to recover. They had intermittent forward and return links, so the burns that they needed on board it was never an issue. It was unusual for it to be dropped out for a couple minutes. So that's what we're telling you. We had a controller issue with the toilet when they spun it up, so we got to work through that. That's going to take maybe a few hours to troubleshoot. So there was also a water tank valve. There's 4 water tanks on Orion. There's a crossover valve that connects the 2 gangs of tanks. It's supposed to be open to ensure maximum flow. It was closed during ascent. When you shake the thing, things like that happen. So they're going to reset the valve. And then they had a recurrence on Artemis 1, we had a latching current limiter failure on a piece of electronics, a transient failure when it gets exposed to radiation. They took 1 hit of those. We took about 24, 25 of those during Artemis 1. Again, normal, the onboard fault detection cleans that up, but we're just getting started, Joey.
Just to be clear, right, this flight test, and a lot of what we're doing here is exactly this, trying to test out all of the things that require the crew interaction, right? And so we anticipate to have a lot of these. Well, that's what we're here for, work through them.
Importantly, apogee raise burn. We're go. So they're going to stay in space.
Sawyer.
Thank you. Sawyer Rosenstein, NSF. I noticed that the slide wire baskets happened to deploy during launch. Is that something that was expected? And can you give any initial reports, at least what you've seen from the cameras, of how the mobile launcher is doing, given the hope to be able to quickly turn it around?
Yeah,
you have something on the baskets. I can talk about the turnaround.
The baskets are, they're supposed to get out of the way. That's part of the plan. So otherwise they take plume loads, and we don't like that.
So I can tell you on the mobile launcher, our team has already been looking at a lot of the imagery that we have that was taken both during and after and assessing that, trying to get the condition. We've got teams, I believe, going out there. They might already be out on their way to take a real look. Some of the good things that we've seen relative to Artemis I, one of the issues we had was that the water that was supposed to be spraying down the launch pad, so that there were some issues there that didn't happen. We saw a lot of corrosion. The water was working, so things were getting washed down. We're still also going to remove some of the parts so that we can do some of that cleaning to make sure we don't have those corrosion issues. We haven't seen evidence of things like after Artemis I, like the elevator doors were blown off. We haven't seen that. So we're optimistic, but we got to get out to the pad. We got to look. We did a lot of changes after Artemis I, trying to harden the systems so that we can turn it around faster. We do anticipate there will be some items that'll need to be replaced. It's a pretty violent environment, but we're hopeful that that's minimized. And as soon as we have more information on that, we'll definitely let you guys know where we stand and how quickly we think we can get it turned around. Thanks.
Lauren? Lauren Grush with Bloomberg. I just wanted to get a gut check on how we're feeling about the upcoming proximity and ops operation. Do we have any concerns with that TDRS delay, or is that not an issue for that?
I would say right now we're on for the proximity operations demo. Haven't heard anything that's keeping us from that, Norm?
No. On track, ready to go. Victor Glover's going to be flying it. Reed's going to be working the procedure with him. And cross-checking, and Jeremy and Christina are going to be looking out the windows, also spotting, cross-checking, using cameras and imagery, and it should be beautiful, so we can't wait.
We'll go right over here.
Yes, Bert Dicht from Ad Astra Magazine, National Space Society. Just wondering if the astronauts reported what the ride was like to orbit. I know with the space shuttle, it was a pretty rough ride until there was SRB SEP. Was this similar?
Have you heard?
I have not heard a report yet. I know we will get a report. Again, yes. When MECO happened, immediately they were getting prepped to do their perigee raise maneuver. That's critical. Otherwise, they come back to Earth, which we don't want them to. So they got that. They are working to get their spacesuits off. They're, they just got the ARB burn, which was very important. So now they're working to get their suits off. So they are very busy. Now, later today, I anticipate they will call down and give us a full brief as to, how the Proxox demo went, how the ride uphill went, and I personally can't wait to hear the comparison between this massive rocket and the shuttle.
Sounds great. Thank you.
Micah.
Thanks, Bethany. Micah Maidenberg, Wall Street Journal. Maybe for the administrator, I'd like to ask you, I know we're early on here, how you're thinking about success for this mission, defining success. A lot of tests ahead. And just what happens if you don't kind of meet that standard as the flight unfolds? Thanks so much.
Well, I mean, to me, success is undershoots and in the water safely after a 10-day mission duration, so no early off-ramps there. I think right now we're already getting good ECLIS data. We've never flown Orion with crew on board, so that's pretty important. I mean, understanding the Orion spacecraft is, it's paramount in this one to progress on to integrated operations of Orion with a lander. Every day we're getting data. It was mentioned from the get-go. This is a test mission for sure. No crew have ever ridden this before. We'll keep gathering data over the next 10 days. We'll share updates, but we'll call success when they're in the water safely, and we'll start working on the next mission.
Jackie.
Hi. Right here. Sorry if I missed it. I just wanted to check in on the status of the perigee and apogee burns. Are those both finished at this point? And then I also wanted to check how the best way to explain to the audience why we're doing that apogee raise maneuver and why we go into that high Earth orbit. Thanks so much.
Do you want to take that? Oh, I mean, I can certainly say we completed the perigee raise maneuver. That was done pretty quickly, as you heard, and the apogee raise burn should have already happened. That should have been happening while we sat here. They were getting ready as we were walking in. And then if you want to talk maybe about the rest.
So we go into a high Earth orbit. Roughly, the perigee is about 1,000 nautical miles, rough, give or take, of the Earth, 25,000. So it's pretty elliptical. That's getting us, everything we do is getting us set up for the translunar injection burn. And so it's getting these burns, it's all converging down to what we call TLI. So we got to get the Eclipse system checked out. We got to make sure we have our redundancy. We got to make sure these burns go off where they should go off and get Orion and the SM configured exactly where it needs to be. So when it comes around and it's time for the translunar injection burn, off we go. And that takes us really, that puts us outbound to the moon. That's a real big commit point. And so you'll be hearing more about that tomorrow.
You might mention it not only sends us outbound to the moon, but it also sets us up for the gravity assist that brings us back. So we are set all the way.
Yes.
Once we make that burn.
Go right back here.
Hi, TJ Mosquera with the Epoch Times. Thank you all so much. Something that hasn't been really talked about is that the Space Launch System predates the Artemis program. We got going all the way back to 2011, so 15 years really invested in this. And just how does it feel to finally see it, launch with the human crew on board?
Yeah, I mean, right now, like I said, we're focused on the next 10 days. But I mean, I'll tell you, I'm incredibly proud of the folks that worked on this machine for as long as they did. And one thing we didn't talk about earlier was, one of the big objectives is getting the organization and getting our qualification standards and getting our certification rigor up to the standard for crewed flight. That's a big, even though the mission is a complicated mission, moving the entire organization to a mindset of thinking about risk in the right way to fly crew is a big deal. And making sure that the way we've gotten the machine configured to fly crew with the resilience and the reliability we care about is also a big deal. So it takes time. I mean, we got a lot in front of us, but I mean, it's for the guys that were out there, it's a big celebration in launch control for the rocket guys. The rocket guys can go out and play now, but the spacecraft guys got a lot of homework, so they're going to go work on that. But yeah, for them, I could see it on their faces.
Jeff.
Jeff Faust of Space News. During the countdown, we heard controllers working through a few issues, one with the flight termination system, one with the launch abort system battery, and it sounded like there was a brief telemetry dropout. Wonder if you could provide a little bit more details about those issues and how you resolved them relatively quickly.
Yeah, so Jeff, the FTS issue was we were doing an end-to-end test. We typically have to confirm that we can get a signal from the range to the machine and then back. We weren't able to close that entire end-to-end loop. But the guys at the range, they were really quick on their feet. They swapped to a different range receiver, which is a slightly different heritage, but has the same fundamental algorithms on it, and they were able to switch over to that and able to confirm a good end-to-end signal, which is really clever. We had thought about getting a receive-only box that we had in the VAB and shipping that over to Patrick quickly so they could do it, but they were able to fix it on the fly over there, so that was good. And once we knew we could confirm the end-to-end loop of that command, then we didn't need that receive. We don't need to do that test more than once. We just need to verify the commands get on board. And so once we confirmed that command was there, then that we met all of our public safety risk. For the launch abort system, we had a battery, so 2 batteries, several temperature sensors on both batteries. We had one poke out of family. We want to make sure all of them are tracking within certain limits. But we could confirm, given the locations of the temperature sensors, where they are on the battery itself, that the reading was instrumentation, because there wasn't a credible physics-based explanation for why that sensor would be that far high. It was an order of magnitude off scale high from the rest, and so we were able to quickly vote that sensor out. So that was two of the major issues. But again, the team, this is what the training is for. This is what the practice is for, is to go into those things and knock them out quickly. So they did really well.
We'll go right over here.
I noticed there was a lack of public address announcing outside, and there was a lot of going back and forth when we realized there were some issues, and we had to go back inside to find out, or we had to have our phones. Why was there no public address system available with loudspeakers outside?
I'm not sure what you're referring to. We're not sure what issue you're talking about the public address. Okay.
Available to people outdoors, and I thought that was a lacking. Which
we'll take a look into it.
We'll definitely look into that. I wasn't aware that happened. So thank you for that information. That's new, and we'll definitely look into it.
We'll go right back here.
Thomas Moore, Sky News. Administrator Isaacman, as a fellow astronaut, what were your feelings watching your crew rising above Pad 39B? And do you feel that extra sense of responsibility for the crew as they head further into space?
I certainly felt that it would be, just from, I guess, my perspective in it, that, I don't know, it is far less stressful to be strapped into the rocket than to be responsible for it here on Earth. So I definitely had those feelings quite a bit. But, you derive a lot of confidence from the process that leads up to this moment. I mean, literally the army of people that came together across NASA, all our contractors, all our partners to prepare for this, every step that leads up to it. This is what I, was really honestly going through my mind through it, is all the testing that goes into it, the integrated testing, the flight readiness review, everything that goes into a flight readiness review. Not to mention you have a truly exceptional crew up there that have been training for years on this. That gives you the confidence to undertake this mission, especially knowing the implications that it is part of a much bigger program. This is America and our partners' return to the moon, and we're trying to do it this time to stay. So, incredibly important mission. Certainly felt the pressure of it, but it was relieved, based on the confidence we have in the team here at NASA and everyone who contributes to it. Thank you for the question.
We'll come right up here.
Frédéric Castel with France 24. First, of course, congratulations to NASA for the grand return to the moon. Mr. Administrator, I have this question that they ask me constantly in Europe and in the States. In the 60s, NASA was using just the slide rule to go to the moon, and they could launch almost every 3 months. Of course, they had more money probably, but what happened in 50 years? Why is it so difficult to make it again? What has changed? Thank you.
Well, for sure, we knew. Look, it's a very fair question. I know a lot of people ask it, not just in your country, but here in the United States. Certainly, financial resources are part of the equation. NASA's budget, if I recall, was somewhere between 4 and 4.5% of the discretionary budget during the space race. About a quarter percentage of that today. And I mean, to be very honest with you, I think competition is a factor in this as well. It's a great way to, mobilize the resources of a nation and concentrate on something extremely challenging, and that's what we did in the 1960s. And I think with absent some competition, we focused a lot on partnerships and all that we could do collectively with respect to science and discovery. But competition can be a good thing, and we certainly have competition now. I think that's why you're seeing us start to concentrate our resources back to the objective, and do it with a great coalition across the NASA workforce, our contractors, all our partners that have come together, our stakeholders in Congress and the administration who came here to witness this launch, is because they know we have competition, and this one's going to be close. And I think as a result, you're going to see a lot more progress, more so than you have in since when this was originally conceived under Constellation. We're going to get back into the business of launching rockets on a regular cadence, and we're going to bring the world along with us. So.
We're going to take a couple of phone bridge questions for just a moment. Reminder that you can join by pressing *1 to get into the queue. We're going to start with Will Robinson Smith from Spaceflight Now.
Hi, thank you, Bethany, and congratulations, everyone, on a good mission so far. Question about the upcoming TLI burn tomorrow. At what point during the day will the team conduct a poll on readiness to proceed into the TLI, and what are the main criteria that you'll be assessing to make that final determination? Thank you.
Okay, well, the TLI burn actually happens about the time that launch happens, so it's one day into the mission. So tomorrow, Eastern time, would be about 6:35-ish. Obviously, those burn times can change, so check that before tomorrow. But what are the teams looking for before TLI? We're looking to make sure that the life support systems work, that the vehicle's healthy, the life support systems have been checked out, they're ready to go. We assure that those are functional because once we commit to TLI, they have to function. And so we want to make sure. So that's why we spend a day checking out the systems. Ascent is, you shake, rattle, and roll a little bit, the vehicle. You saw that today. And you can imagine what that does to the systems. The systems, though, are performing very well. We anticipate that they continue to, but we want to get some track record on them before we do that. We also want to make sure we have redundancy in the system for comm, for environmental life support, propulsion, those type things before we embark on that TLI mission. So that's what the mission control team in Houston will be doing tomorrow. Jeff Radigan and his team, as the lead flight director, will be well into that. The teams are well versed on it. They have trained for it. They work very closely in conjunction with the engineering team, the mission evaluation room in Houston, where the engineers that have the intricate knowledge of Orion come together with the operations team, and together they work with the crew to make sure that the vehicle, is doing what we want to and accomplishing the mission objectives that we need to. But it always comes down to crew safety, vehicle safety, and mission objectives in that order.
And might also mention, as those teams are checking out all of those systems, there will also be a meeting of the mission management team that's led by John Honeycutt, whom I think many of you have seen before, and they'll be meeting tomorrow afternoon to hear all of the results from what's happened over the last day, in preparation to make the decision on whether or not we proceed with the TLI burn.
We will next go right back here to Manuel.
Thank you so much. Manuel Masanti with Exploración Espacial. I understand that the CubeSats are going to be deployed like 5 hours into the flight. Is there any chance we're going to see live images of the deployment? And then when is the crew, I know they're super busy right now, but when are they going to start using the flywheel machine? On its way to the moon when everything is
so,
more like...
The second question was to do when they start doing the manual as far as...
Flywheel machine.
Oh, the flywheel machine. Sorry, thank you. The exercise machine.
I guess after the TLI.
I'll do this exercise.
Yeah, I'll hand that to you, but I can answer the CubeSats. So the CubeSats are installed in the Orion stage adapter, which is actually a part of the upper stage piece, right? So once Orion separates from the upper stage, we'll do the ProxOps demonstration, right? And then once Orion has cleared and we're away, then they will be deployed. So Orion won't be there to take images of them. And once they are deployed, they each of them have their own plans for being able to communicate back down to Earth to various ground stations. They have their own communication plans. So we'll start to get information back from those individual CubeSats. So that's kind of the plan and the path forward on the CubeSat deployment and what you can expect.
We're going to take one more question from the phone bridge from Christopher Mick of the Hudson Star Observer.
Thank you very much. Congratulations to all the teams thus far. I had a question from an earlier media availability with Jeremy Hansen. He made mention of if the mission launched on April 1st, they would be experiencing a lunar eclipse. And I just want to follow up on that, if that's where that would be happening in the mission timeline, and if there would be any video perchance of that happening, or is that just going to be on the astronauts' photography at the time?
So you may have to answer the question on whether or not there'll be the availability of the what kind of real time. I'm not sure what we'll have there, but the crew will get to observe the eclipse. This is pretty unique. It's kind of interesting. It actually doesn't happen when they're out of comm, so they will be having communication during that eclipse time. But during the eclipse, the moon will be blocking the sun. They will be able to see the sun's corona, which is kind of cool. So they've been having a lot of science lessons over the last couple of days to learn about that and the eventuality that we actually launched today. So they're prepared to make those solar observations. It'll be a pretty cool and unique opportunity. I'm sure we'll get some images down at some point. I just don't know if they'll be live.
Tarek.
Thank you very much. Tarek Malik with Space.com for the administrator. There have been a lot of comparisons of Artemis II to Apollo 8, a pioneering mission, daring, that sent astronauts on an untested crewed vehicle around the moon. And I'm very curious, given last week's ignition event and how that really laid out an audacious and ambitious plan to really explore the moon in a stepping stone approach way, where you see Artemis II in that plan, and basically the importance of riding on this mission before you can make that next step for next year.
So, I mean, no matter, I guess, how you slice it, it's the opening act for sure. I think there are areas where we're clearly combining, Apollo 7, Apollo 8 into a single mission. Which we should be able to do. There has been, to your question earlier, there's been substantial progress, over the last half century. We have tools. We've certainly been there before, so I would expect us to be able to get some, mission efficiencies through. But I would say that what we learn from this, for sure, will inform how we think about Artemis 3. Now, there's certainly big picture objectives in that. We'd like to get the lander together. We'd like to test that out in Earth orbit before we go to the moon with it. But if there are things that we don't see, maybe it is comm-related issues, then we're going to try and fix those. And then we're going to want to validate that on the next mission as well. So, and that should be the idea, right, as we progress forward. I suspect when Artemis 3 comes around, we're going to learn a lot about the integrated operations that we'll want to validate and ensure is rolled into the subsequent missions. But yes, this should be a philosophy that we take across all of the grand efforts that we are pursuing right now, to not necessarily jump to the ultimate desired state, but to build up to it.
I'm going to jump right up here.
Hi, Richard Hollingham, BBC Future. Related to Apollo 8 in a way, really. I just wondered what plans had gone into a new Earthrise image. A lot has gone into the aspirational nature of this mission. Have you a plan? I assume you have a plan. What is the plan?
Oh, go ahead.
I do know that the teams have been looking at what the opportunities might look like. They've looked at the different launch dates, and so I know that they're really going to try to make that happen. I can't give you a confirmation on that yet, but stay tuned.
My understanding is they have been equipped with additional camera imagery capturing, equipment. So
we're going to do everything we can to try and make that happen. It'd be awesome.
We're going to go right back here.
Thank you. I'm from a Japanese news agency, Kyodo News. My question is to the administrator. The United States and China are competing over moon development. What significance does today's launch have for the U.S. and NASA? Thank you.
Well, it's certainly an incredibly important step. I mean, this is the first crewed mission into this environment in more than a half century on a rocket that has never flown human beings before, along with a spacecraft. So it's incredibly important because we're going to learn an awful lot from this to inform subsequent missions. So yes, this is the beginning. I can tell you, having had an opportunity to speak with the Artemis II crew after the State of the Union address, we talked a lot about what we wound up sharing with the world at the ignition event about adding additional missions, accelerating production, building out a moon base. I think it was very energizing for the crew because they knew that they were, this is a risky mission for sure. Any type of new test flight mission going in this environment is going to be challenging, and they knew it was building up to something bigger. And I think that I think it was very helpful for them in that regard. So, and certainly it was very helpful for me to hear their feedback as well. I would suspect a point or two wound up in the ignition event from them. So.
We're going to go back here to the white shirt.
Thanks, Denise Chow with NBC News. I think for Lori or Norm, I'm curious what you anticipate could be some of the biggest challenges over the next few days, whether that's from a spacecraft or system standpoint or crew workload.
I'll jump in. Flight day 1 from a crew workload is pretty tough. Between now and TLI, we're working the crew really hard. In fact, when they go to sleep tonight, they're woken up in the middle of their sleep to do the perigee raise burn, and so their sleep's disrupted. They're hitting on all cylinders. They may not be feeling well. On top of that, so we know that flight day 1 and flight day 2 up to TLI is really good. We know it drops off then, and so going into this, we trained for that. We did simulations for this. We put the crew in exactly that state. Now, they weren't on orbit. They probably were feeling great. But we got a good gauge, hey, are we working them too hard? And the mission control team is great because they're watching the crew constantly. They're watching their performance. And we also have a crew that's very good at saying, hey, enough's enough. And so together, we will make certain that we're doing everything in the best interest of meeting the mission objectives, making sure that we're not working the crew so hard that, they make mistakes or something of that nature. And again, we work as a collective team going forward. So this is our best opportunity, and they may add more stuff to the timeline before it's all done, and they may take some stuff out if we need to, but we adjust all the time on those things. So that's leading up to TLI. That's probably one of the bigger challenges, making sure we get those done.
I'm going to go right up here.
Hi, Robert Perlman with CollectSpace.com. For the administrator, you mentioned the 53-year hiatus, and in that time, now most of the world's population wasn't alive for Apollo, like I think you and me. And I wonder if you have a sense of, if even this early in the mission, that this has captured the imagination of those people that have never seen anyone go to the moon before, on a world level, on a national level, and how important is it to NASA to capture that support from the public?
Yeah, I've said it many times. I absolutely think it's foundational for what we do here at NASA to inspire. It should be a component of every one of our missions. I've talked about, I think after Artemis II, you're going to have more kids that are going to dress up as astronauts for Halloween. We want to inspire and create interest in the next generation to grow up and contribute to this endeavor. Now, how have we done so far in captivating the world's interest in America's return to the moon? I don't know. You have to tell me. We've been rather busy the last couple hours. I would say, and I felt this way going into it, that when we got down to T0, a lot of people would be paying attention. I suspect when some of the imagery starts to maybe come back from the moon, that's gonna further bring people into this story. Right, and then we bring them home safely, and we start preparing for, again, the next chapter in the story. So, I think inspiration is extremely important. I think people, despite some of the commentary up to now, how many people really know we're going around the moon? I'm willing to bet right now a lot of people do, and I think we'll only draw in their interest further as the mission proceeds.
I'm gonna go right here.
Robert Coppinger, British Interplanetary Society Spaceflight Magazine. Commander Wiseman said during the crew news conference in September last year that when they get off the planet, they may only spend 3 or 4 days going around the Earth. What sequence of events would need to happen for that to occur? I was quite surprised to hear him be so specific about such a scenario. I know you all talk about it being a test flight. So what would need to happen for that, for the mission to be curtailed in such a fashion?
I didn't cover the question.
So I think the question had, just confirm, it's kind of hard to hear, but the question is that the commander talked about one of the alternate missions where they maybe would stay in Earth orbit for 3 or 4 or 5 days,
yes,
that sort of thing.
What would need to happen
so
for
one
that?
One of the scenarios that would have led to that is if for some reason during the launch that the SLS did not quite deliver us to where we needed to be, or the upper stage didn't deliver us to the orbit that we needed to be in. That would have been one of the scenarios. I think that's probably the main scenario that would have ended up in that one of those kind of alternate missions. Yeah. But I don't think we're going to need to worry about that, hopefully. But the other thing is if for some reason we're able to stay, but we're not able to do the TLI burn, we would stay in Earth orbit. So there's a couple of scenarios where that could happen.
You're right back here.
Hi there, Joey Vars with the Gabber for anybody. In the weeks leading up to the launch, we were talking about some of the distance records and altitude records and speed records that would be achieved that were contingent on the specific day and time of launch. I was wondering if we had a better concept of what those might be now that we are successfully off the ground. Thank you.
Norm has that data for you.
Well, based on the predicts right now, assuming all the burns go as planned and the timeline is executed as we think it's going to be, it'll be on flight day 6. At an MET of about, 18 hours, 18 and a half hours. And again, check that as we get closer because burn durations and things like that matter. But that's where we will exceed or beat the Apollo distance record, or at least that's where we believe that's going to happen. So that'll be an exciting day, and we'll stand by to see what transpires.
You're right here.
Hi, I'm Hanju Yang from Kumin Daily in South Korea. And first of all, congratulations on today's successful launch. And my question is for administrator. And this mission also carried a Korean satellite on board. From your perspective, why does a crewed lunar mission like Artemis II matter not just for United States, but for the global community?
I think we say often that when we undertake these type of endeavors, we never go alone. We go with our international partners. We have a Canadian Space Agency astronaut that's on board this mission. We are carrying a lot of CubeSats from our Artemis Accords partners, and we are going to continue to do this going forward. JAXA is contributing a pressurized rover, a major contribution to our efforts of having an enduring presence on the lunar surface itself. The Italian Space Agency, just a few days ago, we signed a memorandum of understanding for a habitation module on the surface of the moon, a component of the moon base. And to be honest, it was also a key component to the ignition event from last week. Half of the Artemis Accord partners were present. We spent a good portion of the second day talking together, recognizing that some of our partners can make contributions like a pressurized rover or a habitation module, and many others are going to work with their academic institutions and universities for science instruments that could wind up on the Phase 1 component to the moon base itself. So, or interesting tech demonstrations. This is something that NASA is extremely proud of, and will continue to do so as we continue to press forward under this program. So.
We're going to do last question here. I'm going to go over to you in the back.
It's Paul Brinkman, Aerospace America. Can you just talk a little bit about the propellant loading this morning? Was it flawless? Were there any leaks detected? Was it a repeat of the wet dress rehearsal? Did you learn anything?
Yeah, go ahead.
I think it went extremely well. What I heard this morning, and Amit may have an update from later, but some of the leaks that we'd seen of the hydrogen during the tanking for the hydrogen, we saw leaks below 1%, which was significantly lower. Again, the seals that we replaced seemed to perform extremely well. We did a pressure test kind of partway through, and the leak went up to about 1.4%. Still, well within the constraints, which 16% is the bound that we have. So I think it performed extremely well. We actually, I think, finished the tanking early, from what I understood. So I think it went extremely well. So again, the seals that we had replaced out at the pad after wet dress number 1, I think that was proved to be very successful.
And with that, thank you all for coming out and covering humanity's return to the moon. Stay tuned for updates on NASA's social channels, including our continuous coverage on YouTube and NASA Plus. Go Artemis.
Thank you.
This is Mission Control Houston. Thanks for coming back to us. We are here in the Artemis II flight control room, the White Flight Control Room here in Mission Control Center in Houston, Texas, following along with the mission and 4 Artemis II crew members